In this work, we proposed the concept of a so-called safety map, a unified representation for biomechanics impact data and robot instantaneous dynamic properties. It is a novel tool for safety evaluation and safer robot design. Typically, a robot's safety properties are determined for so-called representative configurations or trajectories. Then, they are related to human injury probability or safety metrics. In previous work, we related the robot's input parameters reflected mass, velocity, and curvature to human injury probability in order to obtain a realistic and model-independent safety analysis. Then, so-called safety curves can be determined that provide a maximum feasible velocity as a function of the robot's inertial parameters. The problem with this approach and other existing approaches is that only a local safety analysis is carried out, so no general conclusions about a robot's safety characteristics can be drawn. In this paper, we take our approach one step further. We deduce a rather global perspective on a robot's collision safety. We relate entire robot designs to available human injury data. We propose the concept of a safety map, a unified representation of global or task-dependent robot dynamic properties and human injury data. In the plane spanned by the robot reflected mass and velocity, we can represent entire robot designs in terms of their mass-velocity range. For all human body parts that may be hit during task execution, we obtain the corresponding injury data from a database and also illustrate the data in the safety map. We may now combine the mass-velocity representations of robot dynamic properties and human injury data in order to analyze which robot is capable of producing a certain type of injury. The safety map enables the user to address following, among other questions. Is the considered robot capable of producing a certain type of injury during unforeseen collisions in my application? Where are the most dangerous areas in the reachable robot workspace? How do the robot safety characteristics compare with other performance indices? For example, how dangerous is the robot in its most dexterous workspace? How does the robot compare to other robots in terms of safety characteristics? In the paper and in the interactive session, we describe in more detail how human injury data can be classified and processed towards the mass velocity representation. We also show how the global dynamic robot properties can be derived and provide examples for two robots, namely the LWR4 Plus and the PUMA 560.